Hello all. Today we are solving LeetCode problem number 3129. Find all possible stable binary arrays part 1. So you are given three positive integers which is 0, 1 and limit. A binary array is called stable if the number of occurrence of 0 in array is exactly 0, which is the integer which is being given in the top, and the number of occurrence of 1 in array is exactly 1. It is also the same integer which is mentioned here. So each subarray of array with a size greater than limit must contain both zeros and 1. So this means if limit is equal to 3, it should has both 0 and 1 within it, so which does not mean that you cannot have it means you cannot have consecutive zeros of size 3 or consecutive ones of size 3 as well. It whether it whereas it can be 0 1 0 1 0 0 or 1 1 0, something of this kind, because it with the limit of 3 it should has it should have both 0 and percent 0 and 1% within it. So this is what exactly meant by this limit. Return total number of stable binary arrays. Since the answer may be very large, return it with modulo of 10 power 9 plus 7. So how are you going to solve this problem? First, let us understand this problem with the help of example 1. So we are given 0 is 1 and 1 is 1, limit is equal to 2. So in this case you have only one zeros and one ones to form the subarray, so which means it can be 1 0 and 0 1. So we have only two possibilities, and this two possibilities, if you're checking with the help of limit, it has for the limit of two digits, it has both 1 and zeros covered in these two cases as well. So these two are all the possible outcomes, so we will return base is equal to 2. So this is a very simple and straightforward example. So let us have one more example. It can be the second example where we are having ones one 1 is equal to 2 and 0 is equal to 1, limit is equal to 1. So in this case we can draw a binary tree, not a binary tree, it's a recursive tree where we can form all the possible subarrays, and then we can check using limit if it is a valid or a stable subarray. So since we have 1 1, we will start with the empty subarray. We can have 1 and 0, so which means you will have 0 and you will have 1 here. Now you have to use only 1 0 and you have two ones available, so this will become 0 1, and yeah, this can form only 0 1 1, and whereas this can form 1 0 and 1 1 again, leading to this can further form 1 0 1, and this will form 1 1 0. So these are all the outcomes. Now we have to check based on this limit. I think for this problem the limit will be 2. Yes, yeah, because using that we can able to eliminate some of these uh, possible outcomes. So based on this limit 2, you cannot have consecutive 1 1 and 0 0. So here you have consecutive 1, so this is not stable, and here also you have consecutive 1, so it is also not stable. In this case you have only one stable subarray, so base is equal to 1. So this is the output which we are returning it. So this is a very simple recursive tree decision tree, we could able to make it. Since this problem has a very long solution and we are returning with modulo of this modulo of 10 power 9 plus 7, so we have to follow dynamic programming. So in this case I'm using memoization to solve this problem, and this is the simplest binary recursive tree representation, but exactly how are we going to handle the limit part? So honestly this is a very hard problem. I did not come up with any solution, so this is the solution which I looked up in the internet, and this is pretty efficient. So let us go dive into the solution. So first, for handling the limit, we know that we should have both ones and zeros within the limit. So it is best to assume that if last digit is 1, then the next should be starting with 0, so that you can get the value formed. You can have both zeros and ones within the limit. So if it is 0, it should be 1. So based on this assumption, we are going to build the decision tree or recursive tree, whatever it is. So along with the number of zeros, ones, and zeros and ones with the limit, we will be having a new variable last digit. So we are having 3 parameters and DFS, or we can have it as DP because we are going to solve DP. So DP, we will have zeros, ones, and the last digit. So using this, this is the function which we are using to solve or we are using to build the recursive tree. So before getting into this building this recursive tree, we have to understand one part, that this limit is something which will determine if the performed subarray is valid or not. So for that, we are coming up with the assumption that if 1 is the last digit, the next digit will be 0, and if 0 is the last digit, the next will be 1, so that if these two digits are present within the limit, we will have anyway the stable binary, it's not a binary, stable recursive tree build, and we will get the stable array formed. So it is due to that reason we are having these two functions. So if we want to build it, we will have to start with 1 and 0. So there are only two possibilities. So if we are having empty subarray, this can start with 1, the next subarray can start with 1, or it will start with 0. So in that case, you will have dp of the number of zeros, I can have it as z, and number of ones, and last digit that will start with 1. Again, dp of zeros and ones, and it starts with 0. So this is how it is going to be. We will be building with these two dp functions. So now we will use an example to build a binary tree. So in this case, we are going to I'm going to use ones, or 1, this should be 1 is equal to, oops, this should be 1, and 0 is 2, and limit is 2 as well. So it is due to that reason we will rewrite it dp of 2, 1, and we will start with 1 here. Similarly, we will start with dp of 2, uh, 1 0. So here last equal to 1, so we add 0. Last is equal to 0, add 1 here. So now what happens here is we will place 1 0 and place 2 0 because we have limit up to 2 here, right? So we will place it and then we will test it actually, because we have totally two total zeros we can place it and one 1, so we can form the subarray of size 3. So already we have 1, so we have two more two more spaces left. So now what we can do is we can place 1 1s and 1 0 here and 2 0 here. So now what happens here is uh, before that, how can you will be having a doubt, how are we keeping 1 0 and 2 zeros here, right? So we will iterate it through a loop. So for we will start with 1 till how many times, x times. So how are we finding this x? X will be nothing but minimum of limit and zeros. Why? Because no matter how much is the limit, we will have we can afford, or we can place the consecutive zeros based on the count or availability of the zeros, right? So similarly the same thing applies for placing 1 as well. So we will be using minimum of these two added with 1, because to include it inclusively, to add it, we will be using that logic here. So now we will place 1 0 here and 2 zeros here. So this will become dp of 1 1 and 0, and this will become dp of 0 1 0. So what happened here is we had 0, which means I can write it as 0 and 0 0. So now since the last one is 0, we can place 1. Then what happened here is dp of 1 0 1. The next one should be 1, right? So again this will be placed with 0. This becomes dp of 0 0, and the next digit should be 0. So this is the end. So since these two values become 0, and we will be adding this as one possible way into the ways. So is equal to 1 now, and now we will expand the next one, which is nothing but this. We will have dp of which is I have written that there. So now next thing is we have to place 1 because last digit is 0. So what happened here is dp of 0 0 1. This becomes 0 0 1. So now this is also done. So we will have the ways added as us 2, and similarly I'm not exploring the further path. So because this will be a very big dp, I think here one will be a dead end one, and we will have one more one more ways added to it, and totally the ways will be equal to 3. So we return this as the output, and this is how we will be solving this problem. And with this idea, let us go ahead and build this recursive tree with the help of memoization technique. First thing is we start with 10 power 9 plus 7, and now we have to define the function dp. So def dp, where we are having zeros left and ones left along with this last digit. we have these three parameters, and now we have to we have to add LRU cache because we are using memoization technique. So LRU cache where max size is equal to none. Now let us write the base condition. So it is nothing but if zeros left or zeros left is equal to 0 and once left is also equal to 0, then in that case you will return 1 because that carries the count. So now base is equal to 0, and now we are getting into this part where the last digit is 1. Then you will check the limit check the limit based on that. If it is 0, you check the limit based on that, because there should no contiguous this should be containing both zeros and ones within the limit. So in that case, if last digit is equal to 1, what we will do is we will place 1 to the limit zeros in front. So in that case, for count in range where we start from 1 till minimum of, here we have limit and zeros left, and this will be added plus 1. So plus 1 times, and here if zeros left minus count is greater than 0, then what we do is base will be equal to dp plus or equal to dp of where we pass in the dp minus count, because we are reducing the zeros count by adding whatever possible the amount of zeros by creating that particular subarray. So in that case, if zeros left minus count is greater than or equal to 0, base plus or equal to dp of, we will pass in zeros left minus count followed by ones left, and now we will pass in the last digit, which is nothing but, since here it is 1, this should be 0. So now this is the call, and similarly else part also we have to handle, which is for 0. So we will do the same thing, but we have slight adjustment. So here we have the same thing, but here this is ones left plus 1, and also ones left minus count is greater than or equal to 0. So the base will be here, this should be, count should be removed here, and it should be subtracted from ones left, and this should be changed to 1 because here the last digit is 0. So now end of this loop, now we have to return base modulo mod, and now the time to call the function. So return dp of we will pass in actual, so which is nothing but the 0, then followed by 1 and 1 added with this should be, yes, added with dp of, this is the limit, right? Yes. So last digit should be 1 and last digit should be 0. So in that case, again dp of 0 1, and you also have 0. So this should be mod with the we will perform mod operation and then return the final answer. So mod is the output which we are getting the total number of ways. So let me run it and submit it. It's taking some time. Yes, so there you go. Thank you.